All right, so today we're going to talk about dilations. And when we talk about a dilation, what we are thinking about is we have some kind of figure, whether it be a triangle. And what we're going to do is we're going to blow that triangle up into a bigger size, or we could do it into a smaller size, okay? But what we want to make sure we do is keep the ratio of sides the same. Like if I have a 1, 2, 3 triangle, okay? I want to make sure it's 2, 4, 6, where I double everything. So we're just working on, first off, working with dilations, and then trying to figure out how this connects to our similar figures. So what we're going to do is we're going to apply the dilation, determine if the dilation is an enlargement or a reduction. So when we go from x to y, and it becomes 3x and 3y, that is an enlargement. We are getting bigger, and we should be getting 3 times as big. Now, when you look at this one where it's only a half, that's what we call a reduction. Reduction, the easiest thing to think about is when you're cooking. When you make a reduction, it's like you start with a lot of liquid and you boil off the water, and what's left is a reduction of whatever the cooking agent is, like soy sauce. You can make something super salty by reducing all the water out of the soy sauce and just being left with the remnants of it. So that's what can happen in cooking with the reduction. So when I think of reduction, that's where my brain goes. It just gets smaller. So take your XY values, so whatever they are, from your original figure. And then what we're going to do is we're going to imply, or we're going to, not imply, but enlarge this object. I don't know the right wording right now, but we're going to do it 3 times as large. So what we're going to do is we're going to take that x value and we're going to multiply it by 3. And we're going to do the same to the y. And you should always, anytime you're doing a scale factor, it really should be the same value. So when we multiply the x or the y, both of them should get multiplied by the same value. So we're going to multiply by 3, and we're going to be left with 6, 3, which is our new G prime. That's going to be our image. And we talked about this, our pre-image is where you start. And then we're going to do the same thing to H and then to K. So multiply everything by 3. So that when we're done, we should have 3, -12, and then 9, -6. Now with our reduction, we're going to get smaller, and we're going to get smaller by a half. We're going to take half of it. So we are going to have every one of these to figure out what our new figure is. So we multiply by 1/2, and that's the same as dividing by 2. So we're going to get a -1, and we're going to get a 2. And then do the same thing here. Multiply by a half. We're going to get a 2, because 2 times 2 is 4. And then 4 times 2 is 8. So I know half of 8 is 4. And then last but not least, half this. And we're going to get 5 and -6. So that's how we get our pre-image to our image, are these values. And if you plotted these points, you would get a figure that is exactly half the size. Or you would get a figure that is 3 times the size of its pre-image, where we started from. Where did we start from? Are these ordered pairs. And then we would get half the size figure or 3 times as large. And a lot of times this is what they're going to look like. Okay? So what we want to do is figure out the scale factor. So let's look at C, and then let's look at C prime. So if I look at C, that is 1, 1. And then C prime is going to be 2, 1, 2, 1, 2, 3. 2, 3. Okay? Now, if I think about B, that is -1, 0. And B prime is going to be -2, 0. So is there something that I can multiply these ordered pairs by in order to get the correct answer? And remember, you have to do it to both of them. So when I see 1 times 2 and then 1 times 3, that's not the same. Negative 1 times 2, 0 times 2, that could work. Let's look at D. It is 1, 2, 2, negative 2. And D prime becomes 1, 2, 3, 4, 1, 2, 3, 4. Oh, okay. 4 comma negative 4. Wait a minute. Let's do this. 1 comma 2. Okay. And then 1, 2, 1, 2, 3, 4. Okay, Mr. Schmidt just can't count. That's all. I was like, what is going on here? So, what was throwing me off is I couldn't multiply this by something in order to get this ordered pair. I couldn't multiply this, and I can multiply this. I can see that kind of clearly. Because if I multiply by 2, 2 times 2 is 4. Negative 2 times 2 is negative 4. Multiply this by 2. Negative 1 times 2 is negative 2. But when it came to this one, this was the tricky one, but I miscounted. It's 1, 2. So this is 1 comma 2 for C, and then 2 comma 4 for C prime. Hey, mistakes and wrong answers are opportunities for growth and learning. I think I made mistakes both hours for geometry. Like, they happen. You just have to keep working the system and make sure that it makes sense to you. So our scale factor is going to be a 2. So it's going to get twice as large. And if you look at our black picture compared to our blue one, the blue is the image. So this is the image. So this is our final figure, is bigger than where we started, the black one. So we know it's an enlargement, and it's bigger by 2 times the size. Now, do we have to do all 3 ordered pairs? Not necessarily, but you have to do enough to make sure that you're getting the correct answer that you want. So this is going to be negative 1 comma 2. D prime is going to be negative 1 and a half, and 1, 2, 3. That's going to be 3. Okay. And C is probably going to be the same thing. 1, 2, 2, 2. And then C prime is going to be 1, 2, 3, 1, 2, 3, 3, 3. Okay, so far, not exactly what we're looking for. I can sort of see it, but you might need some more. So let's try B. So let's go 1, 2, 3, 1, 2. So 3, negative 2. B prime. 1, 2, 3, 4 and a half. 1, 2, 3. And that should be negative. Okay. So anytime you want to test something out, here's my suggestion. Pre over prime. Pre over prime. So what is my pre value? Oh, no. Let's try that again. Prime over pre. So we want to take the prime values, whether it's X or Y, take the prime value and put it up top, and then take the pre value and put it underneath. So that we have an idea of what it could possibly potentially be. So if we were to do that, let's try with this one. So our prime value is 4.5 and our pre value is 3. And if I do that, I'm going to get 1.5, which is 3 divided by 2. So let's look at this and see if 3 divided by 2 is going to work. 3 divided by 2 is going to work. And then 3 divided by 2 is going to work. So if I do 2 times 3, that's 6 divided by 2 is 3. 2 times 3 is 6 divided by 2 is 3. So remember, we're taking the x and the y values, multiplying it by this, and you should get this outcome. So negative 1 times 1.5 is going to be negative 1.5. 2 times 1.5 is going to be 3. Oh, so it looks like our scale factor is going to be 3 over 2. Now, if we look at this, this is an enlargement, goes from black to blue, so it's getting bigger. So that makes sense that this has got to be greater than 1. I'm not going to leave that there, but it should be greater than 1. Only when we do a reduction should it be less than 1. Okay? But yeah, looks great. Now let's try our last one, which we'll just do C, but it's a reduction. So let's take a look at that. So M is going to be negative 1, negative 2, negative 3, comma 2. M prime, negative 1.5, and then 1. Okay, so if I do prime over pre, it should be negative 1.5 over negative 3, which comes out to be 1/2. So does 1/2 work? Well, the best way to do this really is take your L, the letter L, 1, 1, 2, 3. So we're going to do 1, 1, 2, 3. And now let's multiply it by our scale factor. So we're going to multiply it by 1/2 and see if we get L prime. So that should be 1/2. And 3 times 1/2 is going to be 1.5, or 3/2. So at 1/2 and 1.5, ooh, look at that. There's L prime. And then we could test K, which is 1, 2, 3, negative 1. Times it by 1/2. And K prime becomes 3/2, which is 1.5, and a negative 1/2. So if we go 1.5 and then down 1/2, oh man, look at that. Best part is I wiped my screen to wipe that piece of black off. It did not work. So our scale factor for this one is 1/2. And that's how you want to do scale factors and utilize them that way. So, kind of the same idea. Remember, our angles don't change. Our angle measure should be the same no matter how big or small our triangle gets, or any of our figures that are similar get. So we have all three angles are equal to each other, but you can see the difference in all of these, where I could put 7 over 3.5, and then I would do 2.5 over in between 125 and 33, 1.25, and then in between here is 4, between 22 and 125, and that's 2. So all of these should get reduced down to a 2. So 2 times 2 is 4. 2 times 1.25, $1.25 is $2.50 when you double it, and $3.50 doubled is 7. So all of these have the same ratios. They all have the same scale factor. So to determine the scale factor, we just did all those. You can continue to practice those, but I'm going to probably get rid of this slide, honestly. All right. Dilation by a scale factor of 1/2 or 2. Translate to the right, blank units down. So when we go from B to F, because it's the second letter is B, the second letter is F, I'm going to go down, and then I'm going to go left. So I'm going to go down 1, 2, 3, 4, 5, 6. 6 down, and then half a unit to the left. don't know why that says right. It is not. Oh. So 2, 2 is 1, 1. 3, 4. Oh. Doing it in the wrong order. So the first thing that I need to do is dilate it by a half. So I want to create a smaller object. So if D is 2, 2, and I cut it in half, then D prime should be 1, 1. B is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So B is 5, 6. 5, 6. And then cut that in half, and B prime is 2.5, 3. So 1, 2 and a half, 1, 2, 3. It's B prime. It's D prime. Then C is negative 1, 2, negative 2, negative 2. Or negative 2, positive 2. That's C. C prime is going to be negative 1, 1. C prime. And there's our figure. 1, 2. So now when we translate it, we're going to translate it 1, 2, 3 units down, not 6, because we have to do the dilation first. And then when we do that, it's going to be over 1, 2. 2 units to the right. Okay. So we're going to reflect, dilate, rotate. So reflect, and we're doing JKL to RQP. So we're going to take this figure and make it this one. So the first thing we're going to do is we'll reflect it across. Well, let's try the y-axis. Let's just see what happens. So I'm going to do 1, 2, 3, 1, 2, 3, and then here. So this is L prime, this is K prime. I want to be careful. I only want one mark there because I'm about to enlarge it, so I want to make it really big. So now I'm going to take J prime, which is 0, 1, and I'm going to increase it by 3 because you can see this figure is huge. So I don't want to reduce my pink triangle to get it even smaller. I want to make this bigger. So I'm going to multiply by 3 and get J double prime to be 0, 3. So 0, 1, 2, 3. So this is J prime. Then I'm going to take L prime, which is negative 3, 1. And I'm going to multiply that by 3 to get L double prime. And L double prime is going to be negative 9, 3. So negative 9, 1, 2, 3. It's going to be L prime. So here's that fixture. And then I'm going to take K prime, which is negative 1, 1, 2, negative 1, 2, and times that by 3 to get K double prime, which is going to be negative 3, 6. So I'm going to go back 1, 2, 3, up 1, 2, 3, 4, 5, 6, and then connect these, which will be Q double prime, J double prime, L double prime. And then triple primes, boom, boom, boom. Because we're just going to rotate this back counterclockwise, or excuse me, clockwise. So we're going to go clockwise, because this is the direction of the clock, 90 degrees clockwise. But remember, 90 always equals 270, and it's the opposite. So it's going to be counterclockwise. So it'll be 270 counterclockwise. Whew, man. Tricky, but you just have to pay attention to what transformations you're doing to get the figure that you want. Okay. So give these test tries, give these test runs. This one's definitely going to just going to get reflected across the y-axis. And then by a scale factor of, I want to assume 3, because I see this is 1, and I see that's 3. Prime over pre. Sounds about right. But, test it out. 1, 1, 3, 3. That's where t prime would be. W prime is 2, 1. Times it by 3. 2 times 3 is 6. And 1 times 3 is 3. So, there you go. So that works. Rotation, we are definitely going to start with ABC. So we want to rotate it, I would say 180. If we want F to be where C is. And then we're going to enlarge it. And then move it left and up. So figure out what those numbers are, give it some practice, and that's what we're doing. Thanks for watching. As my son would say, like and subscribe.